Hello guys, welcome to another episode. So I was having this argument with a friend. He said he prefers Japanese multiplication method as opposed to the usual multiplication method we know. And I agree with him, and he said it's more efficient in ramification, but I disagreed on that aspect because I said that in some cases this method proves more efficient. On the other hand, in other cases it is not as efficient as. So I want us to prove that today by going through it. I'll show you the cases where the Japanese multiplication method proves more efficient than the usual method we know, and on the other hand where it has its own downside. So stick to this video, work with me, let's get down to it. So first of all, what is Japanese multiplication? So in Japanese multiplication, the Japanese represent numbers using place values. These people, they do multiplication by drawing lines and then counting the intersection, the point of intersection. The number of those intersections gives them, the result of that multiplication. So what I mean is they do stuff like this, cross and count 1, 2, 3, 4, and that gives the result. So when I say place values in Japanese, 23 implies 2 tens and 3 ones. That's what it means. 2 tens and 3 ones. Like for instance, 41 implies 4 tens and 1 1. So in that order. So if I say represent 11, for instance, 11 will mean 1 10 and 1 1. So in that order, that is what we mean by place value. So for instance, let's look at this example. Let's say 11 times 31. In our usual way, we'll have 31 by 11, and we'll have 1 by this one, we'll have 3, we'll have 1, we'll have 3, and we'll go this, we have 1 4 3, right? But if we are to go by this Japanese multiplication method, they use lines to denote it. So let's get down to it and see how it's done. Remember I said 11 means 1 10 and 1 1. So we're going to draw this with lines, and the other one in opposite direction where such that they intersect, and we count the dots. 11 will give us 110. So this is 110, for instance. The next one is 1 1. You have to space it. The tens stay together, the ones stay together. So somewhere here we can draw our 1. So this is our 10, this is our 1. Then this thing represents our 11. What about 31? 31 is 3 tens and 1 1. So we have to draw it in such a way that they cross, they intersect. So if we start with our 3 tens, we have first line 1 2 3. This represents our 3 tens. So what about our 1 1? Our 1 1, we can come here and draw it. The idea is that the intersections have their units. So from left to right is 100 tens and units. So you group them vertically. Those intersections that are vertically together go together. So what you do is here now, this represents our 100. These are 100. See these ones in the middle. They go together. This is our tens. So this last one, our units. So we have 100 tens and units. So we go, all right. How many intersections do we have here? We have 1 2 3. 3 intersections. We write our 3 down. How many do we have here? We have 1 2 3. Right? We write 3 down. Down here we have 1. 1. So these two go together. You add them. 3 plus 1 gives us 4 here. So in the unit, we have only one intersection, which is this point. So remember, here is 4. You write the 4 out. So it means that your answer is now 3, 4, 1, which gives you 3, 4, 1. And this is what 11 times that 1 will give you.